Hello friends, in this video I'm going to be working on two examples to help you get a good understanding of what a critical number is and what it is not, right? The two examples, they're going to have slightly different results, and it's just to kind of help you boost your understanding of what a critical number is and what it is not. So before we find a critical number for this function. So I'm just going to do a quick explanation of what a critical number is, just using graph. So just by the side, if I have the number line, let's say x is equal to 2, right? If on this interval, the interval to the left, the function is increasing there, and the interval to the right of 2, the function is decreasing there, then I can say that x equals 2 is a critical number. However, if I have something like this and I have my x is equal to 2, if the interval to the left of 2, the function is increasing there, right, it's going up, and to the right of 2, the function is also going up, then x equals 2 is not a critical number, not a critical number. So at a critical number, the function the is changing from increasing to decreasing, or from decreasing to increasing, just like the way we have in this first illustration. So that's the idea about critical number. At that number, at that x value, the function is changing from either increasing to decreasing or from decreasing to increasing. Okay, so now let's find the critical number for this function f of x equals x cubed over 3 minus x squared. So the first thing we want to do is, so let me write solution. So the first thing we want to do is I want to find the first derivative of that function. So the first derivative of that function, f prime of x, is just going to be 3, bring down the power, then subtract 1 from the power. If you subtract 1 from 3, you get 2. Then you bring down the power for the x squared, which is 2, and then you subtract 1 from the power. 2 minus 1 is equal to 1. So you have that. So if I simplify this is just going to be x squared minus 2x, because the 3 and this 3 is going to cancel out. Okay, so the next thing I want to do is that I want to equate my first derivative to 0. So I have f prime of x is going to be equal to 0. This implies that x squared minus 2x is going to be equal to 0. And from here I can factor out an x. So this is just going to be x minus 2 equals to 0. And then from here I have that x is equal to 0, or x minus 2 is equal to 0. And from this one I can get x is equal to 2, right? So now the x equals 0 and x equals 2, we cannot say that they are critical numbers yet. We have to check. So what I'm going to do is that I'm going to draw a number line. I'm going to draw a number line and locate where x, this is x equals 0, this is 0, and then this is 2. So these two numbers divide the number line into three parts, right? The part to the left of 0, right? The part to the right of 0, which is the left of 2, and the part to the left of, to the right of 2. So three parts, right? So now in each of these three parts, I'm going to pick a number, right, and plug it into the first derivative. So I'm going to pick a number to the left of 0. So I'm picking a number here. So I just want to pick a number. Let me say I pick -1. Pick x equals -1. So I'm going to plug it into the first derivative. The first derivative is f prime of x is equal to x squared minus 2x. So I'm going to plug in -1 into that to check if it's greater than 0 or less than 0, because that way I'll be able to check if the function is increasing or decreasing in that interval. So f prime of -1 is going to be -1 square minus 2 -1. So this is going to be 1 plus 2, which is 3. This is greater than 0. So recall that if the first derivative is greater than 0 on a particular interval, like for each x on a particular interval, then the function is increasing on that interval. So to the left of 0, the function is increasing. So I'm going to draw this arrow, is increasing. Now I'm going to do to the right of 0, I'm going to pick a number in between 0 and 1. I'm going to pick 1. I mean, a number between 0 and 2. I'm going to pick 1. So I'm going to plug in 1 into the first derivative. So I have f prime of 1 is just going to be 1 square minus 2, 1. And this is going to be 1 minus 2. This is a -1. -1 is less than 0. Okay. So since -1 is less than 0, then that is f prime of x is less than 0 in that interval. So I'm going to draw this arrow, right? Okay. Now clearly we can see that 0 will be a critical number because it's changing from increasing to decreasing. But let's look at to the right of 2. So let's pick a number to the right of 2. Let's pick a number. So to the right of 2, I'm going to pick 3. Pick x is equal to 3. I'm going to plug it into the first derivative. So my first derivative is x squared minus 2x. So I'm going to plug 3 into that. So I have 3x, 3 squared minus 2, 3. And this is going to be 9 minus 6. And this is going to be 3. 3 is greater than 0. Okay, so it's increasing here as well. Okay, so we can see that at this point, we can see that function is what is increasing, and then it's 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 decreasing. And at 2, same thing happen. Function, not the same thing in this case, but actually it's decreasing. Then at 2, it changes course and is increasing. So x is equal to 0 and x is equal to 2. They are critical numbers. And the reason is that the function changes course at those points. So x equals 0 and x equals 2 are critical number of f of x equals was the function x cubed over 3 minus x squared. Okay, so now let's take a different example. Let's look at this example. Let's find the critical numbers of this function. So step 1, I'm going to find the first derivative. So let me write solution. Find the first derivative. The first derivative is just going to be 4x cubed minus 12x squared. So if you take the derivative of each of those terms in that function, you get that. Now I'm going to equate this to 0 to solve for x. That's the second step. The second step is you just equate to 0 and solve for x. So f prime of x, I'm going to equate it to 0. This implies that 4x cubed minus 12x squared for 0, and then I can factor out 4 and x squared. So I have 4 and x squared. This is just going to be x minus 3 equals 0. So from here I have is either 4x squared is equal to 0 or x minus 3 equals 0. So from here I have x is equal to 0 or x is equal to 3. So now 0 and 3 will divide the number line into how many parts? Let me draw the number line. Okay, that's the next step. You draw the number line. So this x is equal to 0 and this x is equal to 3. So 0 and 3 divides the number line into 3 parts, right? So for each of those 3 parts, I'm going to pick a number in each of those regions, right? In each of those intervals, and then plug it into the first derivative and see if it's greater than 0 or less than 0. So to the left of 0, I'm going to pick negative 1. So pick here, pick x equals negative 1. I'm going to plug it into the first derivative. My first derivative is f prime of x equals 4x cubed minus 12x squared. So if I plug in negative 1, I get 4 negative 1 cubed minus 12 negative 1 squared. So this is just going to be negative 4 negative 12. This is negative 16. This is less than 0. So on this interval, since my first derivative is less than 0, on this interval it is decreasing. Okay, so now on this interval here, this interval I'm going to pick between 0 and 3. I'm going to pick x is equal to let me pick 1. I'll pick x is equal to 1. This is in that interval. So I'm going to plug it into the first derivative. F prime of 1 is going to be 4 1 cube minus 12 1 square. So I have 4 minus 12. This is negative 8. That is less than 0, right? So I'm going to put this. This is less than 0. Okay. Now, towards the right of 3, I'm going to pick a number towards the right of 3. I'm going to pick, so like on this interval here, I'm going to pick a number towards the right of 3. I will pick 4. X is equal to 4. And I'm going to plug it into the first derivative. F prime of 4 is going to be 4 cube minus 12 4 to the power of 4 square. So 4 cube, that's a 64 times 4. 64 times 4, that's going to be 256. 256 minus 16 times 12. 16 times 12 is going to be 192. And 256 minus 192, that will be 64. 64 is greater than 0. So on this interval, the function is increasing. Okay, so now we can see that at x is equal to 0, to the left of x is equal to 0, the function is decreasing. To the right, between 0 and 3, the function is also decreasing, right? Is decreasing. So that means x is equal to 0 is not a critical point, because at the critical point, the function should be changing from either increasing to decreasing or from decreasing to increasing. But for x is equal to 3, we see that to the left of x is equal to 3, it is decreasing, and to the right, it is increasing. So it changes, right? So to the left is decreasing, and to the right is increasing. So x is equal to 3 is actually a critical number. So I'm going to put here x equals 3 is a critical number of f of x equals x to the power of 4 minus 4x cubed, but x equals 0 is not. And it is not because it's the function does not changes from decreasing to increasing. It's decreasing to the left of x is equal to 0 and decreasing to the right of x is equal to 0. That is between x is equal to 0 and x is equal to 3. So from the first example we did, all the x values we got were critical numbers. X is equal to 0 and x is equal to 2. But the second example, not everything was a critical number. So yeah, so you have to check. You have to check. Don't just solve for the x and say, oh, I found my critical number. You have to check if actually they are critical number. I hope this helps. Thank you.